Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 2-methoxy-4-methylphenyl ether of glycolaldehyde. More precisely, it is 2-methoxy-4-methylphenoxy, substituted compound where the side chain is OCH, CHO, CH2O. The side chain attached via the ring oxygen is CH, CHO, CH2O, meaning the carbon attached to the aromatic oxygen bears an aldehyde, CHO, and a CH2O group. Moving on to the next step. NaBH4 is a mild reducing agent that selectively reduces aldehydes and ketones to alcohols. It does not reduce aromatic rings, esters, or carbon-carbon double bonds under normal conditions. The aldehyde group, CHO, in the side chain is reduced to a primary alcohol, CH2O. So compound A is ROCH, CH2O, CH2O, i.e., the aromatic ether where the side chain is now CH, CH2O, CH2O, A1, 2, 3 triol fragment minus the aryl ether. Moving on to the next step. Ozonolysis cleaves carbon-carbon double bonds. The benzene ring contains 3C is equal to C double bonds as a conjugated system. Ozonolysis of the aromatic ring, aromatic ozonolysis, cleaves the ring. The substituted benzene ring with CH3O at position 1 via the side chain oxygen, CH3O at position 2, and CH3 at position 4 undergoes ozonolysis to give the mosonide-ozonide intermediate B. And for the final step, hydrolysis of the ozonide B with water, reductive workup implied or oxidative, gives the carbonyl alcohol cleavage products. The key fragment from the side chain, OCH, CH2O, CH2O after cleavage of the ARO bond during ring ozonolysis liberates OCH, CH2O, CH2O is equal to HOCH2 CHO, CH2O is equal to glycerol, 1, 2, 3 propanetriol. The side chain after NaBH4 reduction becomes OCH, CH2O, CH2O. When the aromatic ring is ozonolized and then hydrolyzed, the aryl oxygen bond is cleaved, releasing the fragment as OCH, CH2O, CH2O which is glycerol, HOCH2 CHO, CH2O, matching option, B, CH2O, CHO, CH2O. A is a pyruvate ester with no relation to the side chain fragment. C. Glyceraldehyde would result if only one CH2O were present, no reduction of CHO prior to ozonolysis. D. Malondialdehyde would require two aldehyde groups without any reduction step producing alcohols. Therefore, the correct answer is B. Therefore, the correct answer is option B.